Welcome to the MS SQL Tips webcast, Azure Site Recovery and other disaster recovery options for SQL Server cloud deployments, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Our presenter today is Dave Bermingham. Dave is a high availability expert and a Microsoft Cloud and Datacenter Management MVP. And today he will share his experience with working with the cloud and how to protect SQL Server. Before we get started, if you have questions, you can submit them at any time during the webcast by entering questions in the question area in your presentation controls. We will answer as many questions as possible during today's webcast. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. So as Greg mentioned, today we're going to be talking about disaster recovery options for your SQL Server cloud deployments, focusing in Azure deployments, but a lot of this applies to any cloud environment. And we're going to take a closer look at Azure Site Recovery as an option for your disaster recovery solution. So first off, why do we need to plan for HA and DR in the cloud? I mean, doesn't Microsoft already do that for us? In fact, the cloud, just like your own data center, is susceptible to natural disasters. But really, most of the outages we've seen have been user error. So there have been some pretty significant cloud outages that can trace back to some kind of configuration issue, patch issue, and so forth. So you definitely need to plan for HA and DR in your cloud deployments for SQL Server and really any application. So what are your options for high availability? It really comes down to what you're used to on-prem. You have your SQL Server always-on solutions, which include the tried and true Failover Cluster Instance and the AlwaysOn Availability Groups. So those are the two options. We're not going to go into great details about high availability in this particular webinar. We've addressed these topics a few different times over the years in MS SQL Tips. So check the archives. We have some really great webinars on the topic of high availability in the cloud. What we're really going to look at today is disaster recovery options. And so for disaster recovery, in a way, I kind of differentiate high availability and disaster recovery. High availability has a much more stringent recovery time objective, recovery point objective, and it's usually to recover from errors that you kind of pretty much expect to happen. So, you know, hardware is going to fail, SQL Server is going to get into some situations where it's going to stop responding, and you're going to want a rapid failover to a standby server. Disaster recovery, in my mind, is more of that insurance option for something you hope that never happens and shouldn't really happen to you on any regular basis, but still you really need to plan for that worst case scenario. So, of course, the tried and true backup and restore is always an option, and SQL Server, some of the newer versions of SQL Server have the ability to back up directly to Azure Blob Storage. So you could back up your databases to Azure Blob Storage in a different region so that you have your data there should you need to restore and get things back up and running in a different region. We're not going to address that too much in this option. We're going to look more at the data replication type solutions that are going to give you generally a better recovery point objective, meaning you're going to have less data loss in the event of a disaster, and also typically a better recovery time objective, meaning you're not going to spend a lot of time restoring backups to get things back up and running. The recovery is generally push button and within a minute or so in some scenarios. So we'll talk about that as well when we look at these disaster recovery options. So before we get going, I want to have Greg put up our first poll question just to get a feel for what you're doing, if anything, today for disaster recovery of your cloud deployments.
All right, the poll's been launched. So the question is, do you have a DR solution for your SQL Server in the cloud? And I'll just give everybody a little time here to answer that, and then I'll share the results. I'm going to give another 10 to 15 seconds, and I'll close the poll and show the results. All right, I'm going to close it out and share the results. So we have 42% said no, 35% said not currently running SQL in the cloud, and 23% said yes.
Great. So that's some good information. So so hopefully what you learned today, you'll be able to go back and make some decisions, because I think if your disaster recovery plan involves calling Microsoft and complaining, you probably need to have a better plan. So hopefully you'll learn something here today. So when we're talking about data replication and disaster recovery, first thing we have to decide is, well, where are we going to replicate? So one of the options is to deploy a hybrid cloud where you span your on-premise data center into Azure. You can connect either with a private direct connection via express route or a site-to-site VPN connection. And you could use your your primary data center as your DR site if your active deployment is running in Azure, or vice versa. If you're looking for a disaster recovery solution for your primary data center, you could absolutely create a hybrid cloud and use Azure as a DR site. I think a lot of people initially went that route. I'm seeing more common today that people are just embracing the cloud, lock, stock, and barrel, and putting their applications in the cloud. So this is certainly one option, the hybrid cloud. Everything I'm talking about today will work in this configuration, this hybrid cloud configuration. Then the other option is to do what I call Azure Site Replication, where if you're familiar with Azure, you know that there are regions all across the world. So I think there's 30 or more different regions today that you can deploy your instances to. So one of the, obviously a particular region, although it has redundancy within the region through fault domains and update domains, which are applicable to your high availability configurations, still they are susceptible to natural disasters, of course, and even some of those user error, a bad, patch update or user error, we've seen entire regions go offline. So, by moving the data into a different region, you hope to isolate yourself so that you're not impacted from any of those types of failures. So if a single region goes down, hopefully the other region that you've replicated to is still online. And so when we're picking, the region that we want to replicate to, you have to look up, do a search for Azure region pairs, and you're going to find a nice article that talks about what Azure defines as region pairs. So within a region pair, essentially a region pair is two regions typically in the same country where possible. I think southern Brazil is like the only region that doesn't have a region pair in its country. And what happens in a region pair is that the system update has system update isolation, which means that if Microsoft's doing any sort of system update, it will only update one region in your pair at a time. It's going to make sure that the update goes smoothly before it rolls that update to the other region in your pair. So that will kind of hopefully isolate you from any of those user errors that we talked about earlier. Also, if there is a more drastic outage that impacts multiple regions and there's an outage, and we've seen this at least once recently. What they do is they will prioritize at least one region in each region pair for recovery. So they're going to hopefully get one of your regions up and running as quickly as possible. So when they're choosing which, where to do the work, they're going to pick at least one of your regions within your region pair to fix. And these region pairs are typically greater than 300 miles apart to, again, isolate from those natural disasters. It's not always possible. Like the UK is not large enough to have data centers 300 miles apart, so there's 150-mile separation in there. But typically, you're talking 300 or more miles apart between the different regions. And so Microsoft has this list of region pairs on the URL is listed here where you can read all about this. But in North America, they have 4 different region pairs. So if I'm deploying my primary data center in the North Central U.S. region, they will tell me, well, use South Central as my DR site. And same with the U.S. East, go to West U.S., U.S. East 2, U.S. Central, and so forth. So the list is here. You'll find this online. So when you're planning, if you're doing site-to-site disaster recovery, you absolutely want to make sure that you're picking the right DR location depending upon what region you're deploying in. So let's take a closer look at Azure Site Recovery. Now, Azure has been around for a while, primarily introduced for replicating on-prem servers into the cloud for disaster recovery. But recently, they've also added the ability to leverage Azure Site Recovery in that site-to-site scenario. So you can use Azure Site Recovery to essentially replicate the entire instance of your Azure virtual machines from one site to the other, and keep it up to date asynchronously for rapid disaster recovery. And I'll show you that in a moment. But it's really pretty slick. I've went through the process of implementing it. It's not difficult. It's not expensive. I think it's, if I recall correctly, $25 a month per instance you want to protect. And it's really pretty slick. I'm going to walk you through, what it looks like to configure. You're going to go to, and this is the Azure portal. Hopefully, if you haven't seen it before, this is what it looks like. You go to the backup and site recovery options here. And first you have to do is create a recovery services vault. So you're going to give it a name, and to help you avoid some of the pitfalls I ran into first, you definitely want to create a new resource group. And also that resource group should be created in the DR region. Because essentially what they're saying is if your resource group is in the primary region, if there's a failure of that primary region, your resource group is going to be not functional anyway. So create the resource group in the DR site. And then once that's done, you're going to create a new replication job. So we'll click on the replicate here. And first you have to select your source environment. So in this scenario, all my virtual machines are running in US East 2. And I select the resource group that's holding the virtual machines. And then there's some settings you can choose. So you can choose the target resource group, the target virtual machine, target availability sets, and then the replication policy you can create, you can customize, which see here. Essentially, they give you the ability to do application consistent snapshots at minimally once an hour. That's the most granular you can get for application consistent snapshots. But they do replicate continuously, and so that basically every 5 to 10 minutes you should be able to get a crash consistent copy of that virtual machine as well. And you can set the recovery point retentions, so you can configure that replication policy. And so once it's all configured, and you've chosen the virtual machines you want to replicate, to actually implement a disaster, one of the really cool things is this thing here called test failover. So by clicking on test failover, you can choose which recovery point you want to recover from, and you can also deploy it to a specific Azure virtual network. So you could create a virtual network that is totally segmented from your production network, so that you could spin up a copy of your domain controllers and your SQL cluster and so forth, without causing any sort of conflicts, name conflicts and IP address conflicts. So it's a great way to test failover without actually impacting production. But obviously, in the event of an actual disaster, you would click on the failover button, and what it does, and it takes about after you click the button, in my experience, it takes about a little bit over 5 minutes for all the replicated machines to essentially be provisioned and turned on in the DR site. So you got, your recovery time objective is, about 5 minutes, give or take, and your recovery point objective, really depending upon your rate of change, could be as much as 10 minutes for disaster, for a crash consistent copy, or 1 hour for an application consistent copy. So you have those options there. So the recovery time objective, recovery point objective, is not bad. It's not as good as the other options we're going to talk about, but is one of the trade-offs is obviously the recovery time and recovery point objective. The other thing to consider about the Azure Site Recovery is that once you have a disaster and you bring things online in the DR site, coming back to the primary site after the disaster is complete is not quite as easy as the AlwaysOn Availability Groups or the multi-site cluster with Datakeeper, which is more push button instantaneous type failback. Azure Site Recovery is pretty much going to require that you recreate the replication in the opposite direction. So it's going to do a complete resync of all the data from the DR site back to the original primary site. And so that could take some time. Again, depending upon how much data, how large your virtual machines are, it could take hours or even days, depending on how many virtual machines and so forth. So that's one thing to keep in mind as well. It's a great solution. It does have some limitations, but as we'll see later, it's a really, really cost-effective solution for SQL Server, especially when you combine it with maybe you build a 2-node SQL Server failover cluster. We're using SQL Standard Edition with Datakeeper. Very cost-effective and basically no additional cost other than the $25 a month for the Azure Site Recovery for disaster recovery. So it's something certainly to consider. So again, in picture form, we'll talk about the 3 options that we're discussing here today. So option 1, AlwaysOn Availability Groups. Essentially, just like you know and love today, use SQL Server AlwaysOn Availability Groups for high availability locally. So in the US Central, you see I have a 2-node cluster using availability groups. That's doing synchronous replication, automatic failover, and then I'm replicating to the US East with AlwaysOn Availability Groups doing asynchronous replication. So the recovery point objective is really good. We're not talking about a lot of data loss, just maybe a few writes of data loss. Recovery time objective, there's no automatic failover, so you will have to push the button for disaster recovery. But once you do that, it's pretty instantaneous. It'll come online. So we're using that for SQL Server. But as you notice up top, this is kind of illustrating a SAP implementation in the cloud where you have the application servers, the SAP ASCS instance, a clustered instance with Datakeeper. So we're replicating all the other virtual machines associated with this application stack using Azure Site Recovery. because they don't really have any kind of built-in, replication mechanism. So Azure Site Recovery is a great solution for your application servers, your web servers, and so forth. But we can leverage, AlwaysOn for the replication tier. And so we replicate that to a single node in US East 2, or multiple nodes if you want to do that. The second option we're talking about is using SIOS Datakeeper replication and essentially building a multi-site SQL Server cluster. So once again, we'll use Azure Site Recovery for the application servers, and then we'll use Datakeeper to extend the 2-node cluster on-prem to the DR site. The 2-node cluster can be built using SQL Server Standard Edition or Enterprise Edition. Now with Enterprise Edition, it's a little bit more straightforward because you can simply add a third node to your cluster in US East 2, but you can certainly do what we call cluster-to-cluster replication. So you might deploy a 2-node cluster with SQL Server Standard in US Central, and then replicate that to maybe a single node cluster in US East for disaster recovery. And that gives you a very similar recovery point objective to the AlwaysOn Availability Groups. We're doing asynchronous replication across the WAN. So we're talking about maybe just a few writes of potential data loss in the event of an unexpected failure. But the recovery time objective can be faster because you can enable automatic failover. If you absolutely want to have automatic failover for disaster recovery, that's the default setting. So your recovery time objective is going to be even better than the AlwaysOn Availability Groups with the option for the automatic failover. And then finally, the third option that we're discussing here today is Azure Site Recovery in combination with SIOS Datakeeper. And this is pretty exciting. I think this is the first time anyone's talking about it. You're going to hear more about this at Ignite next week. If you go to any of the sessions where they're talking about Azure Site Recovery Manager, there'll be some announcements you'll see as well. But essentially, you can build a 2-node SQL Server Failover Cluster instance with Datakeeper and use Azure Site Recovery to not only replicate all your application servers, but also replicate the 2-node SQL Server Failover Cluster instance. So in this case, you're only paying for 2 virtual machines to run SQL Server and 2, SQL Server Standard Edition, and so you're going to save the money that you would spend by deploying a third node in your DR site and a third copy of Datakeeper. So it's going to be even less expensive, and we'll look at the pricing in a few slides here. But the only downside, of course, is you give up some recovery time objective, recovery point objective, and the failback is not as seamless in that you have to reconfigure it in the opposite direction. But if you're looking for the most cost-effective, and you can live with, maybe recovery time objective of, 5 minutes, recovery point objective of, maybe 10 minutes of data loss, this is a great solution, very, very cost-effective solution. This slide just kind of summarizes some of the features and limitations and advantages of each solution. So across the top, we have the 3 solutions we just discussed. First column, the AlwaysOn Availability Groups for both HA and DR. Middle column combines Datakeeper for local HA with the AlwaysOn Failover clustering, and then also using Datakeeper to extend it for that multi-site configuration. And then the final column is what we just looked at, was combines Azure Site Recovery to replicate the 2-node SQL Server Failover cluster with Datakeeper. And so I did some pricing based on a DS4 instance, which I see a lot of DS4. A lot of DS4 hire is pretty typical in the environments I'm seeing. It gives you 8 cores, supports a premium storage. I configured the DS4 in the pricing calculator. I added 2 P30 disk to each virtual machine for storage. And the monthly cost of that, if you, the first column, if you deploy that with SQL Server Enterprise Edition on all 3 nodes, you're talking, $9,466 a month for that 3-node configuration. In comparison, you could do a multi-site cluster with the center column for $4,758. So the big cost savings there is, as I mentioned, we can do that with SQL Server Standard Edition. So even with the additional cost of Datakeeper in the mix, you still have a solution that's per month half as much as the AlwaysOn Availability Group solution. And then finally, the third column, for a little over $3,000, you can have a 2-node SQL Server Failover Cluster protected with Azure Site Recovery. Also gives you, for a third of the cost, HA and DR. If you look at some of the other features listed here, protect the system databases. If you want to recover your agent jobs, your logins, your passwords, you're not going to be able to do that automatically with the AlwaysOn Availability Groups. It only replicates the user-defined databases. The other 2 options protects the entire instance. Distributed transactions, that's a very limited support. In SQL 2016, they added some very limited support for that. So that's still a big hindrance when you're looking at AlwaysOn Availability Groups. You can't typically support distributed transactions. The other options, you absolutely can support distributed transactions. Ease database administration. Once you, with a failover cluster instance, once you set it up, you pretty much set it and forget it. Any new database you add is automatically part of the protection scheme, so you don't have to manage that on an ongoing basis. If you have other data that sits outside of SQL Server, you have some file share, some application data that needs to be replicated as well, you can do that with Datakeeper. Datakeeper is a block-level replication solution, so you can have a HA, file server cluster or whatever you might want locally. And then Azure Site Recovery, same idea. It's going to replicate the entire virtual machine, so all that data will fail over to the DR site as well. We talked a lot about the recovery time objective. The AlwaysOn Availability Groups, once you push the button, it's very quick. It's going to come online, but you have to be there to push that button for disaster recovery. The Datakeeper multi-site configuration, if you enable automatic failover, it's very fast, will respond automatically, or you can disable it and it's going to have a similar recovery time objective in that manual push button configuration as well. So that's why you see kind of two bullets here. And that's kind of where the Azure Site Recovery falls down a little bit. The recovery time objective is certainly longer than the other 2, but still 5, 10 minutes. That falls into the range of a lot of disaster recovery, service level agreements. A lot of times people say, well, we need to be up and running in 4 hours or 1 hour or whatever it might be. It's still pretty darn quick. 5 minutes to be back up and running is not so bad. Recovery point objective, the AlwaysOn asynchronous replication is very good. The Datakeeper asynchronous replication is just as good. The Azure Site Recovery is also good, but it does have more potential data loss. So they advertise 5 minutes. You could see up to 10 minutes for crash consistent points. And then Failback is the biggest drawback, I think, to the Azure Site Recovery, in that you got to kind of reconfigure it in the opposite direction, wait for the complete resync to occur, and then fail back to the primary site. So that would be one of the downsides there. This slide, just another picture of the cost that I talked about in the previous slide. You see the breakdown of the cost. The compute and storage across the first 2 solutions, AlwaysOn Availability Groups and SIOS Datakeeper, is exactly the same. You got to pay for 2 VMs in the primary site, 1 VM in the DR site, same amount of storage attached to each. So, pricing this out with a DS4 and 2 P30 disk attached to each instance, you get roughly $2,500 just for the compute and storage. The software associated with each solution, as you see, the AlwaysOn Availability Groups requiring the Enterprise Edition, jumps the cost of that solution way up to almost $9,500 per month, across 3 VMs. Whereas the Datakeeper leveraging SQL Server Standard Edition is much more manageable cost associated with that. Again, this is 1 month, so you compound that over time, you can understand the tens and hundreds of thousands of dollars you could save using that solution. And then Azure Site Recovery is even less expensive because you only need to pay for 2 virtual machines, the 2 in your primary data center, and the storage attached to those virtual machines, and then a little bit of additional cost of the software, including Datakeeper and Azure Site Recovery. Very cost-effective solution for a very beefy virtual machine of DS4 is nothing to sneeze at. You're at about $3,000 a month for high availability and disaster recovery. And of course, these costs will go down significantly if you don't need 8 cores and you need 4 cores, but still the correlation remains the same. So SIOS Datakeeper multi-site is going to be about half the cost of the AlwaysOn solution, and Azure Site Recovery in combination with Datakeeper for HA is going to be about 1/3 of the cost of the AlwaysOn Availability Group solution. So let me jump over. For those of you not familiar with Datakeeper, and obviously I work for SIOS Technology, the manufacturer of Datakeeper. I've been with SIOS for 14 years. We've been selling Datakeeper. Datakeeper Cluster Edition came out when Windows 2008 came out, but prior to that we had a high availability solution called LifeKeeper, which combined a replication solution and HA in one package. And Datakeeper is really the kind of iteration of that same replication engine. So it's been in development for well over 20 years. So it's a very robust and solid replication solution. But let me jump to my demo systems here. Hopefully I can reconnect here. All right, there we go. So Datakeeper is in a nutshell, it's a software-based block-level replication solution, host-based block-level replication solution that integrates with failover clustering. So you really think of it as a storage solution for failover clustering that lets you leverage local attached storage. And for many years, the use cases were people were looking for multi-site clusters. They wanted to replicate across data centers for disaster recovery, or people wanted to leverage high-speed local attached disk, PCIe flash storage-based devices, but they still wanted failover clustering, or they wanted to cluster within VMware but didn't want to use raw device mapping. So there's lots of use cases that we've been addressing through the years. The cloud is really where we shine because there is no shared storage in the cloud to let you build failover cluster instances. So if you go out to Microsoft's website, and they'll list SIOS Datakeeper as a solution to let you build a true SQL Server Failover Cluster instance in Azure. So we're in the Azure Marketplace, fully certified HA solution for SQL Server. So what you're looking at, Failover Cluster Manager, we have a SQL Server cluster pre-configured. As you see, it looks like a regular cluster. You get the name, an IP resource, SQL agent. Where we're different is Datakeeper Volume S takes the place of what would normally be a physical disk resource. So in this particular cluster, the 2 nodes, SIOS 1 and SIOS 2, just have some local attached storage. They don't have any shared disk. But what Datakeeper does, if we look at the properties of it, it replicates those local attached disks and integrates with failover clustering. So as far as the cluster is concerned, this Datakeeper volume looks like a shared disk, but when you do a failover, it simply changes the mirror direction Instead of controlling the SCSI reservations, which a shared disk would do, it controls the mirror direction. So right now we see SQL is running on SIOS 2, which makes sense because Datakeeper is saying that SIOS 2 is currently the source. It's replicating at SIOS 1. This mirror is synchronous. It's currently in a mirroring state. And so all that information is gotten through Failover Cluster Manager. So I manage it like a regular cluster. If I wanted to move this instance to SIOS 1, I would do that just like it were a regular shared storage cluster. You see resources go offline and online. Datakeeper switches over quickly. It's already online on SIOS 1. Names are coming online. SQL will start up. That's just like you're used to seeing with a regular failover cluster. I'm going to show you how easy it is to build this type of configuration. So I'm going to jump over to the Datakeeper interface. So again, this is software that's currently running on those two cluster nodes. So we have SIOS 1 and SIOS 2. I've connected to those nodes, and I can get a picture of what those nodes look like in terms of the storage. We see the S drive is currently in a mirroring state, and we see that SIOS 1 is the source, and SIOS 2 is the target, and it's represented up here in that job as well. So I'm going to create a new job and show you how easy it is to get a local attached disk into the cluster. So create a job, give it a name, and then there's a three-step wizard. You choose the source. You choose which network you want to use for the replication traffic, and you could choose which volume you want to replicate. So each instance needs to have its own storage. So if we have an R drive attached to SIOS 1, we need to have an R drive of the same size attached to SIOS 2. In Azure, those volumes can be anything. It can be regular disk, can be a premium storage. It could be a storage space consisting of multiple disks striped together, and I see that very often to get better performance. And it doesn't matter. We support any type of storage that appears as a local block device. So you choose the volume, and then the target, SIOS 2 is good, the volume is good. And then finally, we have the options. So synchronous replication for local target. In Azure, this is what I would do between the two nodes in the same region. For that third node, if I was doing the multi-site cluster, I would choose asynchronous. I also might enable compression to compress that data before it's sent. That's going to save me on bandwidth consumption, which Azure will charge for any egress data leaving a region. So you want to compress that data. You can also specify the maximum bandwidth. This is kind of a quality of service. If you want to ensure Datakeeper never exceeds a certain amount, you can do that here as well. But for a local target, synchronous is the way to go. And we'll click Done. Now in a moment, we'll get a pop-up that asks us if we want to register this Datakeeper volume in Failover Clustering. I'll say yes, go ahead, register that in Failover Clustering. So if I jump back to Failover Cluster Manager here, I go into my storage, I see Datakeeper volume R. It's in available storage. At this point, if I was creating a SQL cluster, I'd run SQL setup, create new cluster, walk through the wizard. The wizard would see the Datakeeper volume R as an available storage location and present it to me just as if it were a shared disk. I'm not going to walk through the entire process of creating a SQL cluster, but I will show you creating a SANless file server clusters just so you get an idea that it really does look like a shared disk as far as Microsoft's concerned. Name and IP. Now here's select storage. It will present the Datakeeper volume R as an available storage location, just like this for a shared disk, and that's it. So next, finish, and I've just created what I call a SANless file server cluster, and it was that easy. Same idea with SQL Server. It works exactly the same way. So we got about 20 minutes here. I think I covered all the material I wanted to cover. So why don't we open up for questions at this point, and I'll stay as long as there are remaining questions to address. So.
All right, thanks, Dave. All right, so the first question, Dave, is related to the management of the cluster. Somebody's just wondering, so do they still manage the cluster the exact same way with Failover Cluster Manager, or do they need to use Datakeeper, or can you just kind of...
Yeah, in a scenario where we're using Datakeeper, you use Failover Cluster Manager to manage that cluster. Now, so there's two scenarios that we talked about where Datakeeper was involved. The first one was what I call multi-site cluster, where you fail over from node 1 to node 2 locally, and then you can fail over to node 3. Now, if you're using SQL Enterprise Edition, everything is managed through Failover Cluster Manager. You can simply move it between all 3 nodes. Now, SQL Server Standard Edition limits you to 2 nodes in a cluster. So 2 local nodes you would manage with Failover Cluster Manager. In the event of a disaster, you would have to use Datakeeper to essentially reverse the direction of the mirror. And then once you've done that, you could bring the DR node online using Failover Cluster Manager. So in that scenario would be a combination of the 2.
All right, another question is related to how to figure out what direction to take. There's just a lot of different levels with the virtual machines and doing backups and database backups and virtual machine backups and replication and so forth. So I'm just wondering, can you kind of give some direction, or does SIOS have some other information or checklist that can sort of help people determine, what is the right path to take?
Yeah, I would say that, backup is a given. Don't stop doing backups, because backup is great for disaster recovery in some scenarios where the recovery time or recovery point objective is not very stringent. But also, backup is great for restoring data in the event of user error. So you can typically store a much greater archive of backups. You might restore a monthly backup, a week, 4 weekly backups, a daily backup, and then you back up every 4 hours, or whatever your backup scheme is. You have a lot of choices to get access to that data. Typically, when you're talking about data replication solutions, you're talking about real-time replication. That is great for disaster recovery. It's great for high availability when you're looking for the most current copy of that data. But if you're looking for the data from 2 weeks ago, it's not going to help you. So Azure Site Recovery gives you a little bit of that option. You saw the retention. You can retain, I don't know what the maximum limit is, but I've seen at least 24 hours that you can retain the copies of your virtual machine. So definitely have a solid backup plan in place. And then for replication, it's kind of a combination of trade-off of cost and features. And the slide I showed you earlier, let's see, this slide right here kind of summarizes some of the options that you have. Now, I didn't address some of the other possibilities, including log shipping, database replication, database mirroring, which is deprecated. There are all other ways to get data from on-prem to another copy. Each has its drawbacks. I really kind of focus on the enterprise class disaster recovery solutions here listed here. But if anyone has any questions, definitely just give us a call. We'll be glad to kind of think through the process with you.
Okay, and just a follow-up. So you do have resources at SIOS that could help people figure out to navigate what makes sense.
Yeah, usually you probably get me on the phone. I mean, we have a pre-sales team, and we'll be glad to talk about some of the options with you. Obviously, we want to help you find the best solution for your needs.
All right, another question is related to using Datakeeper for other cloud providers. Can you use Datakeeper for AWS, Google, etc.?
Yeah, absolutely. AWS, Google, they're pretty much the big three. It's really, Datakeeper is application agnostic, it's platform agnostic. So whether you're running on physical machines, virtual machines, cloud instances, if it's running Windows, you can use Datakeeper. and we have certified with AWS, with Google, and Azure as the three big cloud providers. But any public or private cloud is going to be able to leverage Datakeeper.
And as far as versions go, Windows, everything supported, and same thing with SQL, or are there things that are not supported?
Yeah, I mean, we try to keep it in lockstep with Microsoft. So, we still see, believe it or not, we still see some Windows 2008 R2 out there. 2008 R2 is as far as we go back for operating systems. And then the SQL versions, we are block level replication, so we really don't care what version of SQL. So again, I see a lot of SQL 2008 R2 still in production, but anywhere from SQL 2008 R2 through 2016. We even have, we're not even talking about today, but we have HA solutions in the Linux space. And if you go to linuxclustering.net, there are a couple how-to articles to protect SQL Server running on Linux in Azure. There's one there, and there's also one running in Google. So if you're interested in Linux high availability, it's a much easier solution than trying to roll your own, or with the core sync and everything that is open source. That with the 100-page user guide, this is a very simple off-the-shelf HA solution. It's actually been around since 1999, providing high availability on Linux, so it's kind of tried and true there.
All right, another question, Dave, is related to the site recovery and the failover, or excuse me, the failback. And somebody just wondering, can that all be scripted out, or does they need to manually go through and set everything up again to create the failback?
Yeah, I mean, that's the beauty of Azure, is that you can script most of that stuff. I haven't done it myself, and I don't know the exact. I don't have a 100% for sure answer on that, but I can't imagine that you can't script that that whole process. So I would say yes, but I don't have the details for you, and you certainly will have to put some work into that. But it does, essentially just needs to be reconfigured in the opposite direction. The resync has to complete, and then you basically perform another disaster to get everything back in the primary data center.
All right, another question is related to the servers that are part of a cluster. So somebody's just wondering, number one, do you have to license both of those through AWS? I'm not assuming through Azure. And then secondly, if that is the case, can you have one of the machines a lower version as far as memory, CPU, and just when it does a failover, kind of add it at that point in time? Or how does that work?
So there are some options to bring your own license into the cloud. So if that's the case, and don't really take my word for this, but I'll tell you my thoughts on this. But definitely call your Microsoft licensing specialist. Now, normally you can have, if you have software assurance and you're building an active passive failover cluster, or if you're using like AlwaysOn Availability Groups in such a way that you're not leveraging readable secondaries or anything like that, you can have one secondary server for free. Again, make sure you have software assurance, and make sure you check everything with your licensing specialist. But as you add that third node, there's nothing that I'm aware of that says the third node is free. So you certainly are going to be on the hook for at least 2 licenses. Again, that's if you bring your own license, and you really have to double check with the cloud provider, because it seems to be changing. Every time I look, there's some different wording, so it's hard to really keep on top of that. But if you're going to do pay-as-you-go licensing for SQL Server, chances are you're going to be spending buying SQL Server on each instance. So that's what those cost analyses are based on, paying for SQL Server on all the instances.
All right. Another question, Dave, is there the ability to replicate data between different cloud providers?
Yeah, there's nothing to stop you from doing that. You can certainly span cloud providers with some VPN type connection. I saw someone, if probably you search for this online, someone did that with Datakeeper. They went from Azure to AWS, and they blogged about it and talked about their experience. I haven't seen a lot of it, so I don't know. It does kind of make sense if you want to really isolate yourself from a cloud outage, if you're concerned that there's going to be a cloud-wide outage. I mean, yeah, it'd be a good idea to have your data somewhere else. But again, having it back in your own house might be a better solution because you have control over that and you're not at anyone's mercy other than yourself.
Have you seen any trend as far as people moving to the cloud? Is that sort of the direction people are going? And if so, kind of what are people actually implementing first? Is it just for DR? Is it? You can kind of talk about your experience there.
Yeah. I mean, every time I see a presentation about this, it's the percentage of our new opportunities gets larger and larger and larger. So, SIOS is a software company, and we're in the HADR space. So, we get calls every day for people, looking for high availability solutions, and it's over the past 2 years, it's just overtaken everything we do. I don't know the exact percentage of new opportunities, but it's well north of half of the new opportunities are for cloud deployments. So, and people, again, I would, 2 years ago when I started talking about it, I was like, oh, well, everyone's going to use the cloud for DR. That's, a hybrid cloud. But the reality of it, most of the opportunities I see, full-fledged, just we're moving everything to the cloud. And it's for new deployments. It's for existing data centers that want to migrate to the cloud. It's large, it's small, everything in between. It's cloud, and it's pretty split equally across the two, big cloud providers of AWS and Azure is what I'm seeing. Google Cloud is newer to the scene, but certainly have seen some interest there. Had some opportunities in the Google Cloud as well. But yeah, it's big, and people are just using it as their new data center.
Right. A follow-up question to that is related to sort of a hybrid installation. So, do some people still want to keep things on premises and then somehow using the cloud? And is there a possibility of replicating the data from that perspective?
Yeah, absolutely. Just kind of like this first picture here, where we show the cloud deployment right here. So yeah, you have to connect to the cloud. ExpressRoute is probably the best option. It's going to give you the fastest, lowest latency connection to the cloud. And once you have the connection, it's just like another data center. It's your own data center. You can manage it the way you want. If you spin up some virtual machines in the cloud, you can replicate. Using Datakeeper, obviously you can replicate from machine to machine. Basically block level volume replication of any data, and any kind of software-based replication. The biggest, one of the biggest downsides, or one option is not available, is you can't do array-based replication. So in the olden days, if you had your old data center and you had a big EMC array, you would have to buy another EMC array in your DR site and get some replication software, SRDF, and then you would do array-based replication to keep the SANs in sync across data centers. Now, you can't do that from on-prem to cloud, so you have to go with a software-based solution like Datakeeper that's just going to work with any storage on either side.
Okay, another question, Dave, is related to the learning curve and getting an environment set up. So are there any scripts out there or things that people can just use and run to get an environment set up pretty quickly, at least for development and testing, before they actually go live?
Yeah, there are. So in Azure, there's something called deployment templates where anyone can create an Azure deployment template and publish it in GitHub. SIOS has published some deployment templates in GitHub, which is going to help automate the configuration of the SANless cluster. Microsoft has published their own deployment templates for AlwaysOn Availability Groups. And so that is a great way to spin up something very quickly with minimal knowledge and experience to do to test and also move into production as well. That's really one of the beauties of the cloud is using the deployment templates. You can have a repeatable, reliable script, which is going to be able to spin up these environments for you rapidly in a very predictable manner.
All right, that's all the questions. Dave, you just want to go to the very last slide with the contact information again?
Yeah, that. And definitely reach out. I blog a lot on the clustering for mere mortals. Here we go. There we go. So the contact information is there. Besides this contact information, clusteringformeremortals.com is my blog, and I write a lot of how-to guides on high availability and disaster recovery. And obviously, you can follow SIOS on Twitter. You can follow me at Dave Berm on Twitter. Or just if you have any questions after the presentation, just shoot us an email or give us a call. I'll be glad to speak with you.
All right, great. Thanks, Dave. Thanks for sharing all that information today. And I also want to thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and also to download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.